Now we pay attention to the Fourier coefficients when the function f of x is an odd function. So we need to show that the an coefficients are equal to 0 and the bn coefficients are given by this formula over here, and taking into account that f is an odd function, of course. And we will derive these results starting with coefficients an. Of course, these an coefficients are given by this formula. We can split the integral. Now we name this quantity to be capital I. We work in the same spirit as we have worked with the previous video, where I have made a similar example when the function f of x is even a function. Now let's work out this integral. We change the variable like this, and we also change the limit of integration and the differential. So the limits of integration become from L to 0. The derivative of u with respect to x is minus 1. And we change the differential. We flip the limits of integration with a minus. With a minus here, we have a plus, so this minus sign is killed. Of course, f is, by assumption, we have that f is an odd function, so f of minus u is equal to minus f of u. And this is an even function, and we just kill the minus sign. So there we go. We substitute this back here, and we obtain that we have 1 over L times, we have a minus the integral from 0 to L f of u cos . So these terms are identical, and we have the opposite sign, so we can kill out these terms, and apparently we obtain that the coefficients an are equal to 0. So for the first bit we have showed that the coefficients an are equal to 0. The Fourier coefficients an are equal to 0. Now let's derive the formula for the coefficients bn. sorry, here it's sine, not cos, sine. Let's rewrite it properly. Bn, the integral from minus L to L. And this can be written in the following way. We denote this integral by j, of course. J is this integral. We make this substitution over here and we change the limits of integration. So this can be this limits of integration can be flipped with a minus. This minus vanishes and it turns into a plus. So we have an integral from 0 to L f of minus u times sine minus n pi u over L du. Of course, f is an odd function, so f of minus u is equal to minus f of u. And the sinus of minus n pi u over L is minus the sine of n pi u over L, so it's minus. And finally we obtain the integral from 0 to L this is the j quantity, and we plug in this back to here. So back here, so we obtain that and of course this is 1 over L times 2 times the integral from 0 to L f of x therefore let's put the b coefficients Pn in a box, inside a box. Now in order to sum up, let's write coefficient a n are equal to 0. The coefficients a n are equal to 0, and the coefficients bn are given by this formula. Now the Fourier series is the following. And of course, the coefficients an are 0, so these terms and so these summation terms they vanish, and we obtain only the sine terms. So we obtain only the sine terms. Therefore, when the function f is odd, we obtain only the sine terms in the Fourier series, and the cosine terms vanish.